A few days ago, I uploaded a demo of my procedural island generator. Today I'll be explaining the process behind how it works and the things I did to make it work. So let me begin. The first step of the process was getting reference material, and to be honest, there's not that much previous documentation on this, but using images such as these, I got a rough idea of the final product and I could start working on the terrain generator. For the terrain, I imagined that I had an island texture of say 100 by 100 pixels. Then I could split this texture into chunks of 25 pixels each, giving us a 4x4 grid of chunks. So now we have two values, the chunk detail, which is 25 pixels, and the length/width of the chunks, which is 4. Then I reversed this so that when specified the chunk detail and the chunk's length, it would generate a texture using those values. Now that we know the dimensions of the island and the chunk variables, we can create a script that loops through each of these pixels. The number of pixels to loop through is just the chunk detail times the chunk size, or 25 multiplied by 4. The way we loop through the pixels is a tiny bit different though. As you can see in the script on screen, there is a pair of loops for each chunk, and inside that there is a loop for the chunk detail. This is so we can create a procedural mesh for each chunk and then define the vertex positions ourselves, done in the chunk detail loop. To create a chunk, I just instantiate an empty game object with a mesh renderer, filter and collider. Now I just create the mesh and apply it to the instantiated game object. Now we have a grid of flat colorless planes generated, but to add height and color we need a noise function that returns both of those values. I created a new script, not derived from mono behavior, and started coding. Firstly, to make a function return two values, we need to create a public struct like so. In that, we add a public float for the height and a public color for the pixel/vertex color. Now, when we create the noise function, we can just make the return type of that noise the struct, like so. In that noise function, we create a variable with our struct and make the function return our new struct. Now, with that, we just type the struct's name, dot the vertex color or height, and define the values. This will return two values, the color and the height. Then, to actually use this function, I need to go to the generator script and create a variable that uses the struct we created. Then we assign our noise function to the struct variable, and after passing in the function parameters, we can get the noise value and the vertex color for the required XY position. This is done simply by typing the struct's variable's name dot the value we want, color or vertex height. Now by setting the vertex Y position to the float returned from the noise function and setting the vertex colors to the color returned by that function, we can finally start creating the actual noise. Back inside the noise function script, I created a few float functions that return different types of noise. I warped those noise functions and laid them atop each other to get the combined noise, which I passed into the main noise function. Now the terrain is looking like actual terrain. Just having the noise is not good enough though, as the terrain is not actually an island yet. To make the island, we need a fall-off map. I can just use the fall-off map texture I used in my previous tutorial and apply it to the island. Now, back in the main noise function, we make the terrain height the value returned from the combined noise function, minus the fall-off map, and we make the color dependent on a user-defined gradient. The color component became not as important when I added the terrain shader. This was because I used a shader graph to apply repeating textures to the terrain dependent on height. But it will be important in the future when I add support for different biomes. The reason I added the color section in the noise function is so that the development in the future is more streamlined. The terrain now has hills and plains, but the problem is that everything is the same green texture. To fix this, I added, to the aforementioned shader, a check that if the steepness angle of a vertex is too high, then that vertex color will be set to brown. If you want the shader, it is displayed on the screen right now. You can copy it and apply it to your terrain. Basically, it sets all of the terrain to a green texture, but if the vertex Y component is between a certain range, the texture is switched to a sand color. And then if the steepness is too high, then the color is set to brown. Now we have some nice terrain, but it lacks trees, so that's what I added next. This was quite simple. I just made an if statement inside the chunk detail loop, where if a random number between 0 and 100 is greater than x, then it instantiates a tree at the vertex position. One more condition I added to this if statement was that if the steepness of the vertex is too high, then don't spawn a tree. This was to make sure that none of the rock areas had trees. I also followed AJ Tech's video on a grass shader to make the grass for the terrain. I edited the shader to not render grass below a certain Y value, and I also made it so that the steepness of the vertex is too high, then it won't render grass. Well, finally, I added water, a first-person controller, and post-processing, and a few bird chirp noises, and I think I was done. Well, I hope you enjoyed that video. It was a lot of work to make, so I'd appreciate a like on the video and a sub to the channel. Otherwise, goodbye and I'll see you next time.